Hi all, we are here with our new chapter, chapter 5, nuclear chemistry. Hope you all will enjoy it. So let's start. In this video, we will learn about nuclear equation and radioactivity. Nuclear equation. A nuclear reaction is a change that occurs within or among atomic nuclei and is represented by nuclear equations such as following. Balanced nuclear equation. To understand a balanced nuclear equation better, we will consider the following nuclear equation which is on your slide. As you can see in this equation, the sum of the atomic numbers in the left side equals the sum of the atomic numbers on the right side. Similarly, the sum of the mass numbers on the left side equals the mass number on the right side. This equality demonstrates the fact that electric charge and mass must be conserved in a nuclear reaction. The nuclear reaction is considered to be balanced because both charge and mass numbers are conserved. Natural radioactivity. The phenomenon of natural radioactivity discovered by the French scientist Henri Becquerel. Natural radioactivity definition: the spontaneous disintegration of an atomic nucleus. Why is a particular nuclide stable or radioactive? The answer is related to the ratio of neutrons to protons within the nucleus of the nuclide. Radioactive nuclei break down naturally by a series of processes known collectively as radioactive decay or natural transmutation. In order to become more stable, radioactivity is an attempt to correct the ratio of neutrons to protons. However, stability is not gained immediately. A series of decay reactions may be required before a stable nucleus is finally produced. Transmutation. When the nucleus disintegrates, the process is accompanied by the emission of subatomic particles and/or photons such as X-rays. During the process, one element may change to another. This change is known as transmutation. There are two types of radioactivity: natural and artificial. Natural radioactivity. It occurs naturally. A large number of elements have radioactive isotopes, example C14 and H3. However, elements whose atomic numbers are greater than 83 have no known stable isotopes. Artificial radioactivity. To induce a nuclear reaction, a target nucleus is bombarded with a nuclear particle. In 1919, Rutherford bombarded N14 with alpha particles to produce a reaction in which the N14 was artificially changed or transmuted into O17. This process is known as artificial transmutation. Physicist Sir James Chadwick bombarded beryllium-9 and identified a stream of uncharged particle neutrons. In 1934, Joliot-Curie and Irene Joliot-Curie bombarded Al-27 and produced the first artificially made isotope, P30. Half-life definition. The half-time is the time required for a substance to decay to one half of its initial value. It is another method of measuring radioactivity. Example, I-131, whose half-life is 8 days. If we have 20 mg sample of this isotope, its decay over a period of time occurs as follows. The isotope never decay to 0 mg. It will simply come closer to this value. Does that impact half-life? The half-life is constant. It cannot be altered by changes in temperature, pressure, or chemical combinations. It solely depends on the nature of the radioactive nucleus. Half-time ranges from fractions of a second, like fermium 244, whose half-life is 3.3 into 10 minus 3 seconds, to billion of years, like U-238, whose half-life is 4.51 into 10 power 9 years. The graph of a radioactive process is hyperbola, which is same for all radioactive decay processes. Uses of isotopes, tracers in medical field, and carbon dating. Tracers. Radioisotopes are chemically similar to their stable counterparts, so they can be used as tracers to follow the course of a reaction. This application is particularly useful in determining how certain biochemical reactions occur. Medical field. Radioisotopes are used also in a variety of medical applications that depend on the isotope radioactivity and short half-life. A short half-life is necessary to ensure rapid decay and elimination of the radioisotope from the body. Example: I-131 is used to uncovering thyroid disorders and technetium-99m in performing bone scans. Cobalt-60 and I-131 are used in treating certain cancerous tumors that are considered inoperable. Carbon dating. Certain isotopes are used to determine the age of a sample of material. Example: C14 has half-life close of 5,700 years. This isotope is produced in the upper atmosphere and is incorporated into carbon dioxide along with non-radioactive C12. Tree takes in CO2 and incorporate it into the body wood of the plant. As long as the tree is alive, the ratio of C14 to C12 remain constant. When the tree dies or is cut down, C14 is not replaced and decays. Therefore, the ratio of C14 to C12 becomes smaller as time progresses. By comparing the ratio of C14 to C12 in a wooden bowl to the ratio of isotopes in the atmosphere, scientists can determine the age of bowl with considerably accuracy.